Okay, we're ready to wrap up our chapter with our last radical section. And in this case, it's titled Solving Equations with Radicals in Them. And if you remember, we've solved some equations with radicals in them before when we were doing rational looks. So we're going to show you how some of our problems would be working now that we have the radical in them. So let's get started. And start with just your basic power situation. And we always know that to undo a power, we have to take the root. But remember, when you're solving anything, you're supposed to be getting, in this case, x by itself. You can't do that unless you've isolated it by itself, meaning get it by itself. So I believe the very first step here should be get rid of that 12. So go ahead and multiply. We need that 15,552 divided by 12. And did you get 1,296? But that still leaves an x to the fourth sitting on the left-hand side. And as we know, we've learned that in order to undo a fourth power, you need to take a fourth root. You can either do it with a radical form or with a rational look. And so we know taking a fourth root of a fourth power, we just get x. And then over here, be very careful. We have fourth. Fourth, we know we should be able to get two solutions. Now, what is that one number that we can take to the fourth power to give us 1296? One number, 4 times. It's going to have to be a medium-sized number. Check your calculator. Do the math. You should have gotten a 6. 6 times 6 is 36. 36 times 36, because that would be 4 sixes, gives you the 1296. And as I already said, we definitely need a plus minus. If you don't, then you're not considering, oh, I can have a positive times positive times positive times positive and get a positive, or a negative, 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 negative 4 times and still get a positive. So we get 2 solutions on this one. Not on all of them, but definitely on that one. So let's try this one. We're working with cube root. And again, you always want to isolate your radical, get it by itself. So let's subtract 2. And we'll be looking at the cube root of x, and that should equal 7. Now, our cube root gets undone with a third power. So be careful. This is the root. To undo it, we would do the third power. And we got to do the third power on both sides. So cube of a cube root should leave us an x, and then it's the math that we need, 7 times 7 times 7, and it's a positive 7, so we should get 343. Do not forget on these type of equations, you definitely want to go back and check. So if we were putting it in, whether it's on our calculator or in our head, we're saying, what's a cube root of 343, and then can we add 2 to it and still get an answer of 9? So we just did cube root of 343, that was 7. 7 plus 2 is 9. 9 equals 9, so it checks. So it does work, because there are times when you can get answers that sort of sneak into the picture that don't really make the problem work, but look good along the way. Let's try next one. This time we're back to a square root, and if we solve this one again, isolate the radical. So job 1, get rid of the 5 by dividing. That would leave us with our square root of 3y plus 1. And how many nickels go into 80 cents or $80? How many $5 go into $80 if you like that better? And we should be looking at what? 16? Okay. And from there, we want to undo this square root with a square. That would leave us 3y plus 1. And when we square, we get 16 times 16, which is 256. And now finish, because all we need to do is get y by itself. We'd move the 1 over. 3y equals 255 by subtracting 1, and divide by 3 to finish our work. And when you divide by 3, on both sides, y equals 85. Okay, now check your work, again, mentally or not, with your calculator. So we go back and go 85 times 3, that was the 255, plus the 1 underneath the radical will give us 256. 256's square root was 16, and 16 times 5 gave us 80. And that's what we wanted from the other side. So it checks. We're good. We have no weird solutions or something that looks good that really doesn't work. So solving radical equations is always a good thing. All right, on this one, we've got a sixth root. Probably to start with, let's move this 5 over to the other side and keep that negative sixth root of t. If we move that 5 over, I think we're looking at 729. We got to get rid of that negative sign, and we usually have done that by dividing by negative 1. So if I divide by negative 1, whoops, that's a 1, we would have the sixth root of t equals a negative 729. Now, some of you start looking at that line and saying, Others of you see nothing that's bringing any attention to it. So let's continue. Undo a sixth root with a sixth power. And if you undo that sixth power, we would get t equals. And if I have 6 negative numbers here, that's going to be a fairly big number. And it's a negative underneath. But taken to the sixth power would give me a positive. So that's a huge number. All right, now here's the question. When I was saying, take a look at what we had just in blue on this line. Can you take the sixth root of some number and ever get a negative result? I think some of you are seeing what I'm seeing now. So huge, I'm just going to say here, if you would finish it. But if you don't go and check it, you're going to find out that it's bad. So if I had 5 minus a huge number, because that's what that is, 5 minus a huge number, does it equal that 735? No way. That number will be in the negative. It'll be a false statement. And if it's a false statement, we have something that looks like it is our answer, but it really doesn't work. And it's called an extraneous solution. Look at those first few letters of the word extraneous. It's telling you exactly what it is. It's an extra solution that really does not work when you go and check your results. Okay. Now, on this one, when we say find 2 points on the line, x equals 40, and x equals 40 is a vertical line, so let's just label this. Whoops, let's get my pen back out, not my highlighter, and we'll go to red. So we're now going x equals 40. That's my vertical line. Find 2 points on that line that are 50 units away from the point 1, 2. Now, if that's x equals 40, I'm just guessing that that might be the ordered pair 1, 2. Okay? Now, if that's 1, 2, and we're 50 units away from that line, then we're looking at probably that triangular look. Something up there and something down here. Now, there's a couple things you do know. You definitely know distance formula. The other thing is, and you know that that point 1, 2 is right here, so we have some x, y values. But you also know no matter what this point is, and no matter what this point is, where it intersects, because there are 2, and that's what we're looking for, find 2 points, that they both have what? If they're on the line x equals 40, you know we've got a 40, comma, y value, and a 40, comma, y value up here. And they won't necessarily be the opposite of each other because notice this point was not centered right on the origin. So this one's probably going to be a little higher, and that one will be a little smaller in terms of the numbers. But let's go and use just one of them. So if I used our original point 1, 2, and this lower one, 40, comma, y, into our distance formula, we should be able to figure out what that distance is in our work, and we should be fine. So here we go. The rule is change in x's, so 40 minus 1 is 39, that's squared, plus change in y's, going in the same order, that would be y minus 2 quantity squared. And we know this distance is equal to how much? Look back, I believe they told us. They told us it was a distance of 50. Now look at that. That's nothing more than the equations we were just working with. So let's go ahead and start simplifying it. What do you mean? Well, let's get rid of that radical sign. To undo that, we would have to square both sides. Now we might get a few bigger numbers here, but we still should be fine. Okay. So to do that, we would still get 39 squared, and I didn't write what that number was at this point, plus we have the quantity y minus 2 squared, and that's going to equal whatever our 50 squared is. And notice I'm not multiplying that stuff out yet. All right, let's move this 39 because eventually we need to get y by itself. So we're going to move the 39 squared to the other side, leaving just the y minus 2. And so now it would be 50 squared minus 39 squared. And if we want to do that so that we can get just a number, that's fine. 50 squared minus 39 squared should equal, whoops, whoops, I delete that. So 50 squared minus 39 squared should give us 979. Some of you got to it faster than I did. Then we've got y minus 2, the quantity squared. What do we do to undo a squared? Most of you know we take a square root. So when we take that square root, we get y minus 2, just what was here. And now we're taking a square root in an equation, so be careful. Raise that to the 1/2 power, or take the square root of 979. And we're getting a messy decimal. Square root of 979, and it should be plus minus, so let's just leave it. If that's a messy decimal, let's just leave it as that. Move our 2 over, and we will have exactly what we need. Even though it's messy, yeah, but now we didn't go to that messy decimal. We kept it just as is. And this problem I know mirrors one of them that you're going to start with today. And I'm looking for our example on this one. So now if we have this messy combination, those are our y values. So if you go back to the original problem, we would have our 2 points being 40 was our x value. One of them would be 2 plus the square root of 979 for the y, and the other one would be 40 comma 2 minus the square root of 979. Now, yeah, we could turn those into decimals. That would be very messy, but what's the point here when they were just asking, we got an exact value. If they want them in decimals, there'll be direction that says round to the nearest hundredth or something like that. So we use the distance formula, which is really nothing more than undoing radicals and roots and powers. So we are good here. That will probably be your most difficult or challenge problem, and I know you have one of those right off the bat. So try it, see how far you get. Just be careful. I think yours goes horizontally rather than vertically like mine did. So you have to make a few changes.